Yes, good morning all. My audio is clear. Yeah. Um, so let me begin with another variation of linked list, which is called as circular linked list. I'll just take up one such example and one such function. All others I will be giving you as presentations soon after your third IA. Okay, and once I'm done with this, I'll be beginning with the next chapter, which is called as trees. Okay, and when you come over here during your lab duration, I'll be showing you few of the applications of linked list during the lab sessions. Okay, not right now. So let us begin quickly and end this chapter, and then we will go to the next chapter, which is called as trees. Okay, so shall we begin? Okay, yeah. Let me just take you through the simple circular single linked list that I'm talking about. When I talk about circular list, I have instead of first node, I have something called as last node. Okay, because one of the drawbacks of simple singly linked list is you are reachable anytime to the first node. But reachability to the last node is very difficult because I have to scan through each and every node till I reach the last node. That is a drawback. In order to have overcome that kind of drawback, what the variation will be done is instead of maintaining a pointer at the first node, the pointer is maintained at the last node so that last node is accessible with one go and first node of the linked list is accessible with a jump by one node. Okay, suppose, so how a normal linked list looks like. Normal linked list is something like this. It has a node having info part and the link part. Okay, link part is associated with null when there are no other nodes associated. This you know already. Now the variation to this is instead of storing a null as part of the link part, if there is an independent node, the link part points to itself. It points to itself. It means if there is exactly one node in the list, the circular singly linked list, the node would look like this. I would have stored the element 10 and the link part points to last itself. Definitely this node I call it as last. Okay, this node I call it as last. So last arrow link will be equal to last. This is an extra thing that you are doing for a circular singly linked list. Okay, be it a singly linked list, be it a doubly linked list, this holds the same. Okay, I'll look into the variation of a circular doubly linked list after this is clear for you. So what is a variation? First of all, I maintain a pointer to the last node instead of the first node. Then secondly, the link part of the only node, if it is available, that only node's link part will be pointing to itself. It means that there is a no null at all in the link part of any node at any point in time. These two are the variations for a circular singly linked list when I compare it with normal singly linked list. This is how the circular singly linked list single node looks like. Okay, single node looks like. So instead of returning first, I would return here last. Okay, so guys, shall we write a code for a function insert front in the circular singly linked list? Can you help me out in writing this? Quickly comment. Okay. Shall we build the function for insertion at the front end of the circular singly linked list? Okay, only 2 yes. How about others? Once we start writing, you will get to know about it. Okay, so just pay attention here. If I want to insert 20, I will be inserting in this direction. In the rear, if I want to insert, I would insert last arrow link is equal to temp. Okay, last arrow link is equal to temp. And temp arrow link has to point to first node. Okay, we will proceed ahead in writing the insert front first. Okay, then we will think about the other things. So let us begin writing insert front function. Or do you want insert rear? What function you want, you tell me. Please quickly. Insert front we will write, or insert rear we will write. Insert front. Okay. So let me begin with node. Okay. Node is struct node star node. Type def I have done. That's why capital NOD I have taken. These all things are repetitions. I will not be repeating that. Now node insert underscore front underscore circular singly linked list. So I call it as CSLL. Okay. In bracket, I require the address of the last node, current last node. Initially, last will be null. Okay. Let me just briefly tell that. Initially, last is equal to null. Okay. Now, then what I want? I want the element to be inserted. So let me write int element. Okay. Now, whenever I have a new node to be inserted, first thing that I will do is I will create a node. Okay. So let me write node temp equal to create node. All these things are same, no change at all. Okay. Then temp arrow info is equal to element temp arrow link equal to, what should I write here? Quickly. Are you all woken up first of all? Because your energy is down today. You just have to imagine, okay, before you comment anything. See, whenever I create a temporary node in singly linked list, temporary node's link is always pointing to null, imagining that temporary node is an independent node. It's an independent node. So, an independent node in a circular singly linked list should have link to itself. I will repeat. An independent node in a circular singly linked list must be having the link pointing to itself. So, can I write like this? Temp arrow link is equal to temp. So, I will create a new node. Okay, I'll create a new node. Let me just run this slide. I'll create a new node in this format. How this works? Initially, last is null. Okay, temp I will create. Temp is having 10. Okay, and instead of null, what I will do, I'll make this point to itself. So temp arrow link is equal to temp. Now what happens? I will check if last is equal to null. If last is equal to null, it means what? Last is null, it means temporary node itself will become the last node. Okay, if last is equal to null, return temp. So when you return temp, the receiving variable in the main will be last. So how do you call this function? I would have called this function in main like this. Last is equal to insert underscore front underscore CSLL of last comma 10. I would have called like this. Okay, so last would receive the address of temp. Next time when you call, 10 will be pointed by last. Okay, so I will call this function again now. What I will do, I will do insertion of 5. I'll do insertion of 5. And at any point in time, the temporary node must have a link part pointing to itself. So I will create a temporary node, fill 5 in the info part, link part linking to itself. This is what I do. Then I have to link this to front end of the existing linked list. Right now, the existing linked list has only one node. Okay, I don't bother about how many nodes are there at any point in time. What is my botheration is where do I link this? Okay, the linking has to be in such a format that temporary node has to be ahead of 10. So how the linking has to happen? The linking has to happen like this. This link, which is supposed to be linked to the same node, has to be broken up and the link has to point to 5. Okay, this is what is the first thing that you are doing. This is what is the first thing that you are doing. Or otherwise, what you will do, I have to add 5 and then the 10 has to appear and 10 is pointed by last. Okay, so last arrow link is last only right now. What I will do, last temp arrow link is equal to last arrow link. What is last arrow link? 10 itself. Okay, temp arrow link, that means the temp arrow link is equal to last arrow link. What is last arrow link? Last arrow link is last itself. Okay, if there is exactly one node, this is the case. Now let me take up one more example. Let me just run the slide again. Okay, and let me take up a pen. Once you understand this, then nothing will be difficult for you. Okay, now you just imagine that you have inserted 20. Okay, and initially 20 is the element to be inserted. Temp arrow link is equal to temp and return temp. When you return temp, last gets overwritten, so this node will become the last node for the next call. Next, I will insert 10 in the front of the list. Okay, so temporary node gets created. Temporary node has 10 as a value at the info part. Link of temp is pointing to itself. Okay, now at this point, what should I do first? I should remove this link and attach the link to the first node of the linked list. Who is the first node? Can you tell me in the existing linked list, who is the first node? The last node itself is the first node, correct? So how I can get the address of first node? At any point in time in the circular singly linked list, at any point in time, how do I get the address of first node of the linked list? I have last node's address. How do I get the address of first node's address? What is the way out? Yes, what about others? It is last arrow link. So whenever you write last arrow link, it will point to the first node. Look at this picture. Okay, this is the last node. Last arrow link is the first node. So one step ahead, if you go, it will give you the first node. Okay, now when you are inserting any new node at the front end of the list of the circular singly linked list, the link of the temporary node, has to point to the first node. It has to point to the first node. So what is the first node? How do you get the first node? Last arrow link. Okay, so I'll write temp arrow link is equal to last arrow link. Okay, whichever node be the first node. Right now, the last node itself is the first node. So temp's link gets connected to 20 itself. Okay, then once this is done, what is next I have to edit? I have to edit this link. But why? I'm upgraded with different first node right now. Okay, previously it was only one node which is the first as well as the last node, but now the first node has changed. Okay, so in order to incorporate the new first node, what is that I need to change? Last arrow link. Okay, so what I will do, I'll cut this link. How do I relink this? Last arrow link is equal to temp. So the link would come back to 10. Are you getting this point? Are you getting this point? Or any doubt you have? Okay, let me explain it. Let me explain it by taking one more example. Okay, yes. You just imagine like this. There is a 10 available. Okay, there is 10 available. When you want to insert the first ever node, if last is equal to null, return temp. It's as simple as that. Nothing changed. Now, if last is not null, if last is not null, if there is exactly one node available, what is that I will do first? I will do this first. What is that? Create a temporary node, assign a value to it, okay, and make the link of the temporary node point to itself. This is what is done in these three steps. Please have a look at, map this diagram with the code that I have written. Okay, temp arrow info is equal to element, temp arrow link is equal to temp. So every time the link part is pointing to itself if it is an independent node. Okay, now what I am supposed to do is the link part of the last node, because there is exactly one node, is pointing to itself. First thing that I will do is 5 has to be attached before 10. Okay, so definitely the link part of this temporary node has to be attached here. Has to be attached here. So I can write temp arrow link is equal to, okay, temp arrow link is equal to. How can I get the link of this? By telling last arrow link. Okay, last arrow link is the first node. The node available is only 10, which is itself is the first as well as the last node. So what is that I did? Temp arrow link is equal to last arrow link. Okay, now this node and this node are linked. Next, what I'm supposed to do is, I'm supposed to remove this link, reattach that link here. So this link got detached now. Temp arrow link was equal to temp initially, but now temp arrow link has become last arrow link. Next is last arrow link I have to detach and I have to attach to the new first node. Okay, so last arrow link is equal to temp. Last arrow link is equal to temp. Okay, so now what has happened? This is gone. I will be ending up with 5 here and 10 here. Any doubt at this point? I'll take one more example where two nodes are there and if I want to insert a new node now. Okay, please pay attention. I would have created a temporary node, which is the third node that I'm inserting at the front end of the list. You just imagine 5 is the new node to be inserted and link of this is pointing to itself and I have called it as temporary node. Now can you tell me what are the steps that I need to follow? Can you guess? Right now I have 10 and 20 and last is pointing to 20. Last arrow link is pointing to 10. So what all are the possible steps in order to make sure that 5 gets attached at the front end of the list? Can you comment? Okay, temp arrow link is equal to last arrow link. What is the link part here? What is the link part of temp? Temp arrow link is equal to temp, but actually temp arrow link has to be last arrow link. So I have to remove this link. I have to remove this link and make this link to be attached here and this link attached here. So first thing that I'm doing is attach, first step that I'm doing, attach temp arrow link is equal to last arrow link. Right now last arrow link is 10. Okay, so temp arrow link is equal to last arrow link, and then reassign last arrow link to temp. So shall we write the same code? Shall we write the same code? Please let me know from your end. So I will write if temp equal to null. What is that I need to write? Can anybody comment? Sorry, if last is equal to null. I'm sorry for it. If last is equal to null, so what should I write? Return temp. Return temp, because the node that is getting created will become the new first node as well as the last node. Otherwise, what should I write if it is not the case? Can I write like this? Temp arrow link equal to last arrow link. Okay, temp arrow link is equal to last arrow link, and then last arrow link equal to temp. Now check out. So you just have to imagine like this. There is a new node getting created before 10. Okay, then 20's link will be pointing to 10. So what is that I need to write? 5's link has to be pointing to 10. How can I write that? Temp arrow link equal to last arrow link. Then this link which is available in 20 has to be overwritten, and it has to be attached to 5 instead of 10. That is done by last arrow link is equal to temp. Correct. Now I think somebody has commented in the chat, I have to return last. You are right. Okay. So what I will do, I will simply write at the end of this, return last. Yes, tell me, have you understood this or any doubt you have? If understood, please type yes. Okay, shall we take up one more example of insertion at the rear end? Okay, insertion at the rear end. Let us go ahead. You have to help me out in writing this code. Okay, so let me write node insert underscore rear underscore circular single linked list of node last comma int element. Now go on telling me what should I write. So let me create the node first. This I will complete. Node temp create node equal to create node. Then temp arrow info equal to element. Then temp arrow link equal to temp itself. Okay. Next, what is that next thing that I need to do? Jaldi. So what is the base condition for circular single linked list? Guys, what is the base condition? Correct. If last is equal to null. Correct. So let me write if last equal to null, return temp. Holds good. Next, otherwise, if not, what should I do? Okay, somebody has commented probably. Let me just check. Praveen has commented. Last arrow link is equal to temp. Temp arrow link is equal to last arrow link. And last is equal to last arrow link. Okay, let me check. So let me just run the slideshow. Okay, let me draw this and then let us analyze it. You just have to imagine that I have inserted already 10. Okay, This is a base condition. I have done it already. So let us imagine 10 is the element inserted and the link part of this is in pointing to itself, and 10 is right now pointed by last. Now I am trying to insert 20. Okay, I am trying to insert 20 at the rear end of the list, and it is an independent node. That's why the link part of temp is also pointing to itself. Okay, it is as good as two circular singly linked lists available at once. Now I want to link 10 to 20 and 20 will become the next last node. How can you do this? What is the first step? Please note, if I remove this link first, you would lose the address of first node. So you don't dare to touch that link first. First of all, you have to link this node to the first node and then attach this node to this and then move last. So how can I write this? I'll give you 2 minutes of time for this. I'll tell you the steps again. First thing that I will do is attach 20 to the first node. How can I reach the first node? Last arrow link. Okay, so I'll tell temp arrow link is last arrow link, remains the same as usual in case of insert front. Then you have to link 10 to 20 and move the last node or move the last pointer. This is what is the required steps. How can you do this? 2 minutes for you. Yes, let me read out. One of you have answered. Temp arrow link is equal to last arrow link. Okay. Then last arrow link is equal to temp. Return temp. Fine. Let me just check the first one that is been written. Temp arrow link is equal to last arrow link. Last arrow link is equal to temp. Last is equal to last arrow link. Yes, well and good. Any other answers? Okay, Praveen. Any other answers? Or is it the same? See, I'll tell you a hint. Okay. Um, in this example, insert front, you had returned last. Okay. In both the cases, insert front or insert rear, you are doing the same two steps. No change at all. You are doing the same two steps. But the address of the node which you are returning, that matters. That matters. When you are returning last, you are trying to insert at the front end of the list. When if you return the address of temp, you are returning the address of the new last node. So instead of writing return last, if you write return temp, it will become insert rear function. You can check it out. Let me write it and show you. Okay. If last is equal to null, return temp. Otherwise temp arrow link equal to last arrow link, then temp arrow link is equal to last arrow link, then last arrow link equal to temp, and instead of writing return last, I will write return temp. And who will be receiving in the main function? Which variable receives the value that is returned from this function in the main? last it is. So instead of giving back the last node's address, if I give or if I return the address of temporary node, that itself is nothing but insertion at the rear end. It is the simplest part that you have to understand in circular singly linked list. Okay. Same functions remain, no change at all. Insert front and insert rear, both are one and the same. Okay, but only thing is that you are returning that matters a lot. Okay, I think Praveen has asked me a question. If you update the last to temp, not an issue, not an issue, then there is no need of returning. See, I think probably I have answered this question when you were asking the same question in singly linked list. Okay, if you don't want to have any return type, what you can do is you can write last is equal to temp. Both are one and the same. Any doubt at this point? Now, can you write display function for circular singly linked list? I'll give you 2 minutes of time for doing this. Okay, your 2 minutes begin. Display all the nodes in the circular singly linked list. ఏంటి సార్ ರಾಮಚಂದ್ರ ಸರ್ ಕ್ಲಾಸ್ ತಗೊಳ್ಳಿದ yes the display function what should be the termination condition for displaying? Okay, let us decide by drawing a diagram. Okay. Okay, let's take 10, 20, 30, 40. Okay, these are the nodes available and my circular singly linked list would look like this. Now, how can you start displaying these nodes? Where last is pointing? Last is pointing to 40. Now, if I want to print all the nodes, okay, how can you do this? Okay, while current not equal to last arrow link. Okay, let me take up something like this. If I write current is equal to last arrow link, where current will be pointing? Quickly comment. Where current will be pointing if I write current is equal to last arrow link, the first node. Okay, so what I will do, I will start from the first node itself. Okay, current is equal to last arrow link. So if I do that, current will be pointing to the first node. Now what I'll do? Until current not equal to last. Until current not equal to last, I'll go on displaying the nodes. It's as simple as that. So can I write while current not equal to last, printf %d current arrow, sorry, double quotes complete, comma, current arrow info. Then I'll write current equal to current arrow link. Then let me write printf null. This is the overall display function. So shall we go ahead in navigating through the loop? While current not equal to last. Okay, what is current right now? 10. So enters the loop, prints 10. Current goes to 20. 20 not equal to 40's address. Okay, so goes inside, 20 gets printed, current comes to 30's address. 30's address not equal to last node's address, so enters again, 30 gets printed and current comes to 40. Now 40's address not equal to 40 fails. So what should I do for this? Print last individually. You're right. So you have to print the last individually. So what I'll write? Printf %d slash null, comma, current arrow info. Okay, this is the overall display function for the circular singly linked list. Are you getting this? All three functions are clear or not clear? Please let me know from your end. Is it clear? Type S if you have understood it. What about others? Understood. Okay. So what we will do is, we will skip all other functions. Can you try them on your own? Please let me know from your end. Anyways, after third IA, we will be having what is called as presentation from your end. Okay. So at that time, we will take up all these things, all these functions presented by one of you. Okay. What all remaining now? Delete front, delete rear, search and print. Okay. Count the number of elements and find the number of occurrences of a given element. Okay, insert after a key, insert before a key. Okay, all those things are still remaining. Okay, so I will be assigning those things to you. Please be prepared with those things. Then what else? Priority list. You are right, Srinivas. You are inserting the elements in the ordered manner. Okay, that is also still pending. So please try these things on your own. I hope so. Yes, guys. So after your third eye, we will take up all these things. Okay. Say yes if okay. Okay. Now let me just go and begin the first part of the next unit, which is called as trees. Okay. So I'll just brief out how a tree is, what is tree about, and then I'll stop the class. Okay. After your third eye, I'll be beginning with the trees in depth. Fine. I think probably it is on next Wednesday. Next Wednesday, I'll be taking the trees chapter in depth. Yes. So till now, whatever data structures you have come across, all of them are linear data structures. I call them as in one dimension the things are taking place. Be it insertion, be it deletion, be it the searching, whatever operation that you have applied on the data structure, all those operations, be it an array, okay, simple array if you take, all of them are taken care in a single dimension or in a single direction. Okay, now I call something as hierarchical data structure, which talks about one linked to another, one element linked to another in such a manner that the linking is not at all in the straightforward manner. I have to reach to that node or reach to that element through hierarchies, stepwise. Suppose you just imagine at the root of the tree or at the beginning of the tree structure, there is 10 available. I want to reach to an element 5. The elements in the tree or elements in the data structure are arranged in such a manner that all the elements that are lesser than 10 are on the left hand side of 10. All the elements that are greater than 10 are on the right hand side of 10. Okay, if I have to do like this, and in such a manner that the element which is left to 10 is again having the same property. 10, say 5 is the element which is before 10 or below 10. 5 is in such a manner that the element which is coming inside, if it is lesser than 5, it has to be on the left side of 5. If it is greater than 5, it has to be on the right side of 5. So if this condition holds good for every insertion, then I talk about what is called as hierarchical data structure. And one such example which talks about hierarchy is trees. Trees can be of various categories. Okay, it can be, see, the based on the number of hierarchies per level, number of splits per level, the kind of tree is decided. If imagine one node is having 3 subparts, it means at level 1 I have one node and at level 2 I have 3 nodes which are linked to this node, If this is the case, then I have a tree which contains every node having 3 children or 3 child nodes. Any node which is at higher level is called as parent of the lower level nodes, which are directly connected to the nodes. Okay, so there is something called as dependency matrix available in the tree, and that is called as hierarchical data structure. Okay, so we will take up in depth of this in the next class. So for your third IA, you have a portion as follows. You have queues, queue data structure. You have linked list, all forms of linked list, especially the singly linked list and doubly linked list. Okay, any kind of operation can be asked on singly linked list and doubly linked list. All varieties of queues. Okay, be it insertion time priority queue, be it deletion time priority queue, ascending priority queue or descending priority queue, or even you can have simple circular queue, you may have linear queue. Okay, all these stack and queues implemented using single linked list, stack implemented using doubly linked list, all these operations, okay, they all of them are included for your third IA. Any doubt in the portion? Okay, so shall we end the class? No doubts. Thank you. Shall we end the class? Okay, probably tomorrow I'll not be taking your class. I'll let you know again by tomorrow. Let you know by tomorrow. Okay, thank you all.